Good afternoon, friends. Last lecture we have to end of the Poisson-Kahn reaction in the ring formation reaction. Okay. Therefore, we have to discuss the second reaction, that is a Burman cyclization reaction. Okay. In this Burman cyclization reaction, therefore, it is a thermal cycloaromatization. Okay. Burman cyclization means it is a thermal cycloaromatization of the enediene. Okay. This is the structure of enediene. Okay. Therefore, you have to thermal cycloaromatization of this enediene, which proceed via the formation of benzenoid diradical. Okay, which is proceed means you are to producing, this is the enedine's product, and that enediene product, it is a proceed via the formation of benzenoid diradical. Okay, this is the two benzenoid diradical you have to formation, and then you have to form the enedines. Okay, and that benzenoid diradical, it is known as Burman cyclization reaction. Okay, it is known as Burman cyclization reaction. Definition is simple. That definition is about the thermal cycloaromatization of enediene. Okay, cycloaromatization of enediene, which proceed via the formation of benzenoid diradical, it is known as the Burman cyclization reaction. Okay, the second point, it is says that the high temperature required for the cyclization to occur the cyclohexadiene act as a proton donor. Okay, means at high temperature, it required the cyclization of the reaction. To occur the cyclohexadiene act as a proton donor. Okay, this is the introduction part of the Burman cyclization reaction. Look at the general reaction. This is the alkyne component. Therefore, in presence of 150 to 200 degrees Celsius, in presence of benzene cyclohexadiene, you have to produce the aromatic ring. Okay, that is the aromatic product you have to formation by this alkyne starting component. Okay, look at this mechanism is a very simple. At the high temperature, you have to formation of the diradical, the benzenoid diradical. Okay, look at this diradicals. Okay, then this is R1, R2, this is one radical. Okay, this is also the one radical, therefore this is the double bond. Okay, and then this is the R3 and this is the R4. Okay, so therefore the benzenoid diradical you have to produce, that is the Burman cyclization. Okay, this is the Burman cyclization. Nextly, you have to use the cyclohexadiene as a proton donor. Okay, at the high temperature, therefore it required the cyclization reaction to occur the cyclohexadiene act as a proton donor, means in presence of, okay, this is your product, that is R1, R2, then this is R3 and R4. This is the diradical product. In presence of cyclohexadiene, okay, so this is the benzene cyclohexadiene. Okay, therefore you have to know it is a proton donor. Therefore the one proton, it is a donate from this radical. Okay, therefore this one radical means one electron. Okay, therefore its hydrogen, it containing one electron, and this is one electron. It is formation of the sigma bond. Okay, it is formation of sigma bond. Okay, then your product is R1, R2, then this is hydrogen. Okay, and this is R3 and this is R4, and this is another radical. Okay, then anotherly you have to another treated with the benzene cyclohexadiene act as a proton donor, Okay, therefore this is R1, R2, H, this is R3, and this is R4. Okay, this is the product of the Burman cyclization reaction. Okay, so this is the mechanism of this Burman cyclization reaction, and this some of the example of this Burman cyclization example. Okay, write down, that is the one. This is the product of the alkyne in presence of benzene cyclohexadiene. Okay, in presence of 2 times of benzene cyclohexadienes. Okay, in presence of at 37 degrees Celsius, at 37 degrees Celsius. So what is your product? Okay, then second example is about the product is about okay, this is the product in presence of lithium bromide and ACOH, lithium bromide and ACOH, and in presence of DMSO, okay, in presence of DMSO at the water molecule at 37 degrees Celsius, or in presence of the cyclohexadiamine, okay, as a proton solver. Okay, that therefore this is the 2 example, and that 2 example in the Burman cyclization reaction. Therefore it is all about the Burman cyclization reaction. It is a simple method, that the method it is says that you have to thermal cycloaddition, okay, thermal cycloaromatization. Okay, you have to form the thermal cycloaromatization, and that is the indamine cycloaromatization of indines. Okay, this is the indines which proceed via the formation of benzoate diradical. Okay, proceed via the benzoate diradical. Okay, this is the benzoate diradical, and therefore it is known as Burman cyclization reaction, and this is your thermal cycloaromatization reaction. Okay, this is the thermal cycloaromatization product, and this is your example. You have to solve it. Any difficulty for this example, you have to chat with me on the WhatsApp, and therefore you are any query you have to solve them. Okay, therefore this is all about the Burman cyclization reaction. Next time we have to discuss the Nazarov cyclization reaction. This is the last reaction in the third topic, that is about the ring formation reaction. Okay, thank you.